everybody, the Head Chemist. So today we're doing another video in atomic structure and electron configuration. So let's get moving. Bam! Today we're doing the electron configuration, orbital box diagram, and quantum numbers for Fe, that's iron, but a cation of iron. That is iron with a 2+ charge. So I want you to think about that. You are going to certainly use your periodic table, but you also need to know what an iron 2+ charge is. So here's a hint. Okay, there is iron. It's a Z of 26. Metals lose electrons to form cations by the following set of rules. So you're going to remove electrons from the highest N, that's the shell level, with the outermost subshells first. That is, you're first going to remove any of the same N value, F type, then the D, then the P type, and finally the S type within the same principal quantum number. So we're going to write out the electron configuration for iron, so make sure that you have seen the previous video. What's the largest principal quantum number? It's a 4 for 4s2, and then it's a 3d6 for iron. So we're going to remove how many electrons? It's a 2+ charge, so we're going to remove 2 electrons. So that's why we have the following electron configuration for iron that's a 2+. So it has an argon noble gas core and 4s0 3d6. Okay, that 0 I'm designating there so that you can understand that I have lost the largest principal quantum number, which is a 4, and of the largest principal quantum number, there's not a 4p for iron, there's not a 4d for iron, there's not a 4f for iron, and there is a 4s. So that's why we're removing that one. Okay, so hopefully that corresponds to the 2 electrons of which have been lost. Now what we're going to do is we're going to do the orbital box diagram of the same iron that's a 2+ charge. This is a cation of iron. Okay, so we're going to write out the orbital boxes as is appropriate, and then you're going to think, do I fill in any electrons in the 4s orbital or that box? The answer is, do I have any? No, I don't have any because I've lost them. So the answer is no, I'm not going to fill in any in the 4s box. But I am going to fill in the 3D box just like I did before. So I'm going to have an up, an up, an up, an up, an up. And this is following Hund's rule. This is maximum multiplicity. This is the same parallel spin electrons in different orbitals. This is lowest in energy. Okay, now I only have one more electron. I'm going to backfill it, and it's going to go right there like that. Hopefully that makes sense. Is this paramagnetic or diamagnetic? That's the question. So do I have any unpaired electrons? I still have the same number of unpaired electrons that I did in the atom of iron. And that is 4 unpaired electrons. So this is paramagnetic. Okay. Now, the 4 valence electrons have been removed from the iron. When you look at the noble box diagram, the orbital box diagram of iron, you should see that iron 2+ charge, and we're going to do another one in the next video of a 3+ charge, and you're going to see why the most predominant form of iron is a 3+ charge. Okay, so now we're going to circle an electron, a random electron, and we're going to get a set of 4 quantum numbers for that particular electron. So we're going to circle this one here. So you're going to write out these electron set of 4 quantum numbers for that blue circled electron. Then you're going to start the video back up again. So N is the principal quantum number. What is this in? It's in a 3D subshell. So N is equal to 3. Okay, then what type of orbital? It's a D. Okay, so therefore the L value for a D-type orbital is a 2. That is, S's are 0. P's are 1, D's are 2's, F's are 3's. So N of 3, L of 2, and then you're going to label the boxes. So you're going to start with the middle box at the top there, okay, of the D subset, and then you're going to put that 0 there, and then a 1, a 2, and then to the left of the 0, a -1 and a -2. So which box is that highlighted arrow in? It is in box number 1. So the M sub L value is a 1. Then, is that arrow going up to heaven, and that's positive? Therefore, the M sub S value is +1/2. So here are the set of 4 quantum numbers to represent that particular electron. Note that this is not the last electron in iron that's a 2+ charge. It's just a randomly selected electron for this particular ion of iron. Okay? So hopefully that worked out well for you. Hopefully you understand that you're going to be removing, to form ions, to form cations, and metals lose electrons, you're going to be removing the outermost electrons with the largest principal quantum number first. That's key. That's why we didn't remove 2 of the electrons from the 3D, because there's a 4s. The 4 is higher in principal quantum number than the 3. Okay, that was another crazy hat video by the Crazy Hat Chemist, and I got a crazy hat here for you. Hopefully I can spin my little whirly bird. All right. If you like that video, give me a thumbs up. Please subscribe to my YouTube channel, and I will see you next time for more cool chemistry videos. Bye now.